Hey, what's up, guys? Welcome back to Coffee Time. This is Armin again here, and today is 23rd of September 2023. Without further ado, let's go to the next part of Solidity, which is here data location, storage, memory, and Calldata. What it wants to say? Storage variables are declared as either storage, memory, or Calldata to explicitly specify the location of a data. Storage variable is a state variable stored on the blockchain. State variable. Okay, a state variable is just the same, just other name, storage, because you wanna put this directly on blockchain. Okay. Storage. For storage, let me come here. Let's see, we have here a contract. This is example of Solidity. First of all, we want to read this. After that, we go to write some codes. Here is unsigned array of unsigned integer, which is public, and the name is R, a state variable. This is state variable. We have other mapping, unsigned integer, addresses, map, a list, which you learn, and a struct, unsigned integer, foo. Okay, other mapping, my structs. And now let's see, storage variable or a state variable. We know how it works. And now let me go here. I have made here data location example contract, which is, I have here a state variable which is stored in blockchain or storage. Storage is just blockchain. Okay, this variable, when initialized, is going to store in blockchain. Okay, this. Okay, I have here unsigned integer public storage data, and now let's see function to set value in a storage. There is a function to set that value in blockchain. Okay, very simple, very easy. Here, set it, and now we have other function to get. And now let's come. I want to say, just let me say here, I have here a function with memory data. Memory data variable is in memory, and it exists while a function is being called. What is the other name of memory in other programming languages? For example, if I'm coming here, I have here a variable. This is C#. I have here a variable. Oh, API key. I have here a variable which is local. Okay. Memory variable is just local variable. It's going to fire off when you call that function. Let me come here. This is memory, and I'm coming here, and I say here, here. Memory variables. Okay. Here. Just that's local. And the point is this. Just this is local, and you learn it in the last other parts. Okay, we have here a function f, call f with state variable. Here, this is a function which is going to call this one. Okay, and here is the point. If you look here, you are going to call that function with your data, which is now here, create struct in memory. Okay, these are memory variables. It's just temporary, but a storage variable is not temporary. Okay, let me come here. Let's see memory. Okay, let's see now a local variable in Solidity, which is now memory. We have here a function, do something with memory, unsigned integer 256 value, pure, nothing. It has nothing to do with a storage variable, and it calculates some separate. It has nothing to do, when you say pure, has nothing to do with other things. It only reliable. It's only rely on self. Here it accept a value which is not coming from the blockchain. It's coming locally, and then here we make a new variable, memory variable, local variable, and then result is equal to incoming value times 2, and then I'm going to return that memory, return local. Okay, this wants to say this memory this function, I mean this variable, unsigned integer 256 result is only available in this function, and only in this function is only available when it's called. Okay, here result. You cannot get access to result from other function because this is just memory. Okay, and now let me come here. Here, Calldata, a spatial data location that contains function argument. Function argument. Okay, let me come here. The Calldata is a data location where the data parameter of a transaction or call is held. Non-modifiable, it wants to say you cannot change it, read only. Okay, you cannot modify or change the data in Calldata. It cannot be overridden, constant, something like that. You cannot change it. Okay, and let me see here. ChatGPT. I'm going now to ChatGPT, and I say here, write example to show Calldata in Solidity. For example, let's see here what we get here. Let me copy this here. Let me see, I can read it here better. Let's see here. We have here I don't know, because this is just, we have to read it. We have here state variable, event, which is function update data, string memory new data, string memory new data, and new data store data is equal to new data is just setter, and you're going to call that event. Get data is also, because get data, because you want to return store data, that is view. Okay, because it's depend on something else. And now function to demonstrate receiving and processing Calldata. Okay, a string Calldata new data. Okay, and it's going again to return only here, nowhere else. Okay, you can perform any data processing here. For this example, very simple, new data. Okay, it's Calldata, only Calldata, just call it. And let me see here, for example, Solidity Calldata example. And let me come here, let's search on internet. I want to go also to let me, for example, I don't know, let me see what we find. Struct, what the heck is this, Big Daddy? My, let me go to CoinMarketCap, find, we want to go to which coin, which contract, I don't know. Let's see which contract we get. Storage is the easiest grasp. Okay, let me come here. Memory is reserved for variables that we define within a scope. Okay, within a scope. Calldata is an immutable temporary location where the function argument are stored and behaves mostly like memory. Behaves likely like memory. Okay, between memory data, that's the point what I want to show. Between memory data and Calldata, there is a difference, but it's something just the same. Okay, but there is well differences, but there are actually the same comparison. When you define okay, so memory and Calldata are allowed in all functions regardless of their visibility type and that thing. Okay, let's come here. Let's come here. We don't have anything here. Let me go to a contract here. Which contract we wanna see? We wanna see, go to Polygon. Let's see, or we get something here in Polygon contract. And here I'm going to click there. After that, Etherscan, which is now, come on baby, I'll put it here, just enter. I have really bad bad PC right now, because yeah, 1 year later, bro. Okay, let's come here to the contract and interface save and function to in this balance owner view. That's not what I wanted. Function return boolean here. Approve, require address not null, allow message sender value, and here make those things. We transfer from nothing there, increase it, and here transfer from internal, emit transfer mint require allowed mapping here. Look at this struct, and in that struct we have a mapping. Look at this struct, and in that struct we have a mapping. Just okay, let me come here, add, you say here function add role, here role, a storage role, here storage role. Okay, only storage role here. You see that storage, this role, because you can pass that in a function argument here, as you see here, contain function argument. Okay, and here role storage, and I want to say here again remove the role. So why they need a role here? Give the account access to this role. Function add role storage role. We have, let me see here, storage role. Let me see here role. Okay, if you check here, that's the point. You can use that storage data in a function also. Okay, and here we have in a storage we have a mapping of a role, and now we want to change that mapping when we want. Okay, we have an address. We want to say, hey, this is the address of administration who get access to make some changes. Okay, here require account not 0, and here require has role account. Okay, it say this address should be empty or not role anymore, or never had a role. Okay, and then role barrier account here true, storage variable. You see, storage variable here. Very nice. And now let's so here remove. But why they need this? They remove the account to access this role. What is this? This is just a smart contract, and require the exact the same has here. This is the function has. It's going to check view. It wants to say we wanna check blockchain data. Here we have these roles on blockchain stored, and we wanna now check that is a view. Okay, and here just has function. Here it say there check the account has a role or not. This is going to check or the account is a boolean. Okay, check or that exists or doesn't exist. Contract pauser role. Okay, pauser role for roles, then roles event pause. Okay, with other word, they pause contract when they want. Here they give access to someone, to a wallet, and that wallet is be able to stop everything, just shutting down for a while, or just shut down. If you pause this contract here, if you're going to pause this contract here, okay, here no one can sell or trade or whatever. Okay, and here roles, we have here just the roles. With these roles, where coming these roles from, you know that here. And we have other things here. Okay, let's go further. Let's see, this is interesting. Okay, and now this is role, and then constructor add pauser. This is constructor, just this contract, this piece of code, which is now, look at this is a contract, huh? This piece of code, which is now 50 line of code, this is going to set pauser role who is be able to pause that. Modifier require, here we said that is required to be that first of all that it paused. If that is paused, and here we are going to declare add pause, and this is really bad. Renounce pauser function, renounce pauser, remove pauser, because we have it in constructor, do not forget. Okay, and now other contract going to implement this one because this is inheritance. This contract is going to just is this pause rule here, and then here we go further. When I say this is that, mean all this function become accessible to this contract, you know that. Okay, event hatata, when paused, when not require, just if contract is not paused, for example, and here pause only pauser, when not paused, and unpause, and here just we have other contract which is going to implement those all here. Super, because this is going to implement via inheritance. Super wants to say the current one. Okay, and now a string. Here we have the main one. Here in constructor we give a name of that contract, and hatata, a string memory here. Memory comes from constructor, and here set things here. These are not, and contract matic token is all, and constructor just that, and this is just storage call data, and yeah. In the next one we want to make an example or just practice here to for better understanding, and just have a nice day, and see you in the next one, and ciao.